Hello children, welcome back to physics class. Today we are going to explore a very fascinating and fundamental concept of mechanics, that is the law of conservation of momentum. So let us begin our journey into this amazing topic. So here we go with law of conservation of momentum. So what is this law of conservation of momentum? States that the total momentum of a system remains constant if no net external force acting on it. I repeat, the total momentum of a system remains constant if no net external force acts on the system. That means if net external force acting on the system is zero, the momentum of the system remains constant. So this is the statement. The total momentum of a system remains constant if no net external force acts on the system. External forces, any external forces, in absence of any external forces, the momentum of the system always remains constant. Okay, let us try to explain the same conservation of momentum with respect to the Newton's third law of motion. Children, you remember the Newton's third law of motion? That is, for every action there is an equal and opposite reaction. So based on that, let us try to define the same. Okay, if a number of bodies are colliding with each other, then the total momentum of the bodies before collision is equals to the total momentum of the bodies after collisions. That means if number of bodies are colliding with each other, the total momentum of the bodies before collision is equals to the total momentum of the bodies after collision. Let us try to understand the same, the simple illustration. So for this, let us consider two balls. One is a stationary ball, that means which is at rest condition, and let us suppose another ball which is moving with certain velocity. So as I told you, this is a moving ball and this is a stationary ball. So whenever this moving ball collides with a stationary ball, do you know what happens? So this ball, the stationary ball, after collision will start moving. Okay, that means it gains some velocity. Earlier it was at rest condition, now it is moving with certain velocity. Its value, that means its velocity increases from 0 to certain amount, whereas the velocity of the first body decreases. Because after collision, because of collision, the velocity of the first body decreases, whereas the velocity of the second body increases. Initially, first body was at rest, the other body was at rest, first body was moving. Second case, this rest body gains velocity and starts moving, whereas the velocity of the first body decreases. Clear, children? Now coming to the momentum. The momentum is defined as product of mass into velocity. Okay, so as the velocity of the body, first body decreases and the velocity of the second body increases, this implies the momentum of the first body, that is mass into velocity of the first body, decreases, whereas the momentum of the second body, that is mass into second body, this is m2 and this is m1, this value increases because of the increase in velocity. That means the momentum of the first body decreases, whereas the momentum of the second body increases. How much is it increasing? So whatever the momentum of the first body decreases, same amount of momentum is increased in the second body. That means the loss in momentum of the first body is equals to the gain in momentum of the second body. From this we can conclude that the total momentum of the two bodies, that means the total momentum of the system, remains constant before collision as well as after collision. So now